In this problem, we're given the amount of work required to stop a 45 kilogram cart. Yep, grab my pen. We're told the amount of work required to stop, and we're given the mass of the cart. And the question is, if the cart was stopped over a distance of 3 meters, what was the magnitude of the force? So we know we're going to be looking for force. Let's go back through the problem and see what's given. The first thing I see is that 12,000 joules of work was needed to stop the cart. Now I know that if 12,000 joules of work was needed to stop the cart, then the cart also had a kinetic energy of 12,000 joules. And I may or may not need that information in this problem, but I like to write it down just to remind myself of that relationship, just in case. And then the next thing I see is that the mass of the cart is 45 kilograms. And one more thing, it looks like it was stopped over a distance of 3 meters. So the distance is 3 meters. So I've given quite a bit of information. Let's see what we need to know to solve the problem. So I'm looking for force. And I know that force is a part of the work formula. Work is force times distance. And I have distance, so I think that's probably what we'll use. Work is force times distance. Now it's important to point out here, or at least interesting, if not important, that there's things that we're not going to need that we're given. We're not going to need to know the kinetic energy. And mass is not going to play a factor in this either. So that's not unusual. A lot of times in physics problems you're given more information than you need, but it's always a really good idea to write down everything you're given just in case you see an alternative way to solve the problem. And there often is different ways to solve the same problem. But in this case I'm just going to go with the straight work equals force times distance problem. So 12,000 joules equals the force, which we don't know, times the distance, which we do know, 3 meters. Now from here, pretty simple process. We need to get force by itself. So we're going to divide both sides by 3 meters. Which cancels that out, leaving me with force equals. And I get 12,000 joules divided by 3 meters. So I'm going to have 4,000. And then my units are joules per meter. And that's a pretty interesting way of looking at force. So again, remember that a joule is a Newton meter. So if the meters cancel out, then my answer is 4,000 newtons. And there's the answer to the problem.